right, ladies and gentlemen, let's take some roll now. It looks like again you guys be careful. Remember, this is a face-to-face class, and so you want to be here. But sometimes like here, even though we try to broadcast, this internet connection down here in the basement's not good. The wireless isn't good, and so it just went down right now on us. So, in case you guys didn't know, so I'm glad you're here. Which you should be here, but some people, that's not how they roll. I mean, they're gonna want to stay home and not get out of bed and stuff. So anyway, so I'll have to try to upload this video later when I get a chance. And so if people are at home at the moment, only even though they can't hear me, just want to remind them. But anyway, let's take some roll. See who's here, who's not here. Okay. Jessica Bareilles, is Jessica here? How about Angel Barrientos? Angel here? Genevieve Barrios. Okay. Looks like Brian Corretto. Brian? Victoria Castillo. Tiffany Chor. Tiffany Chor. Elizabeth Dela Cruz. Destiny Degadillo. Destiny. Shannon Eduardo. Okay. Alejandra Flores. Edgar Gonzalez. Samantha Gutierrez. David Guzman. Jiayu Lee. Jimmy Lee. Yoon Lim. Okay. Good morning. Adrian Lim. Adrian Lim. Sandra Yamas. Okay. Hoon Lee. Hoon Lee. Christian Martinez. Christian. Brian Malgar. Christian Moria. Damian Munoz. A Mio. Gabriela Beatrice. Jamie Ramos. Giselle Rivas. Sebastian Rodriguez. John Saldivar. Eric Soon.
Morning, sir. How are you today?
Good morning. Thurian Theet. Thank you. Jocelyn Sill. Varela Vasquez. Olivia Velasquez. Siyu Wang. Lauren Wu. Jun Kong Si. Haley Yan. Sarah Zahui. Patrick Zamora. All right, Patrick. Okay, anybody here who's enrolled in the course and I did not call your name? Yes. Cabrera. Did you oh yeah, we got you, Julian. Sorry. Julian here. Okay. You enrolled yesterday. Okay, I'll get the updated form if you guys enrolled yesterday. So let me double check. Is Angel Barrientos here? No. Is Tiffany Chor here? She should be here. Anyway, okay. All right. So we got this information. Yeah, like I said, ladies and gentlemen, even though you try to broadcast, it may not go through. So you want to be here. All right. Let's go to let's go to my website so everybody can understand a few things. Okay, so I'm going to my website now. So you guys are actually Math 261. So when you go to my website, like for example, you say, where do I go? www.ddjudge.com. And like I said, oh yeah, the internet. Oh shoot, internet's down. Well, I'll have to show you. Well, no, the internet's not down. It's too slow to broadcast. So there's a difference. See how slow it is? So we'll wait. We'll wait. There we go. Oh. I'm looking for Math 261. Okay. Okay, Math 261. So I want to share some things here with you. So there you go. Okay, so yes, you can see what'll come up here is some links. And you say, here's my syllabus, here's my schedule. Okay, so I want to go down to this thing called worksheets and videos. All right, so go down to worksheets and videos. I'll even put it in the, well, I can't put it in the chat because it's not really there, I think. I don't know, well, let's see, let's double check as it loads. So you go worksheets and videos, yes. Not sure. Okay, and now you might see there's a whole bunch of worksheets and videos. Okay, you guys see what I'm saying? There's a lot of resources here for you guys in calculus. Calculus is some serious business. It's no joke. So what I have, first of all, curves, every B student should know. So this is going to take a while because it's a file. So curves, every B student should know. And again, I'll put that in the chat. I don't think it'll be there, but weird. So as it loads ever so slowly, curves, every B student should know. Traditionally, you guys want to know what these curves look like, okay? Because they save time and energy for you as you do your work. You're going to see when they come up. And if you don't know what some of those curves look like, well, you're on the first day, you're going to look at that sheet and you go, okay, I want to go through that sheet. I want to double check and I want to see how everything should look, various curves. Because, you know, graphically speaking, it's very good to reference that information so you can understand some concepts. So, you know, if for example, you don't know what some of those graphs look like historically, it's kind of difficult to do a lot of the work. You know, you communicate with people and they don't know what you're talking about. Yes, we'll look at graphs, but you want to know what those things look like. So I'm kind of waiting for it to come up slowly but surely. Oh, geez. There we go. Curves every B student should know. Like, for instance, here's a line. F of x is x. F of x is x squared. So in theory, you guys had these topics in like a pre-calculus course, intermediate algebra, pre-calculus, college algebra, because they graph these things. They graph them by what's called translation, you know. So, okay, and you look at these curves, x to the third power, right? X to the fourth power. X to the fifth power, x to the sixth power. So all those things. Square root of x, right? Cube root of x. Those are all some important curves to know. They're very fundamental curves. X, the fourth root, the fifth root, and there's a pattern. You might even see this looks like the square root. This looks like the cube root. It does. There's patterns to these curves. The sixth root, and then you got the absolute value curve, right? So these are all those curves you guys translated in a pre-calculus setting. 1 over x squared. Okay. 10 to the x, e to the x, exponential curves. You guys studied all those curves. pre-calculus. A log curve. You guys studied those curves. Beautiful. Oh, and then you have what? Sines and cosines. That's what? Trigonometric curves. Oh, wonderful. Study those, hopefully, right? Cosecant, secant. Studied those curves. What is this worksheet called? Curves every what? B-STEM students should know. It used to be when my daughter was, my first daughter. When she was born, I wrote curves every calculus student should know. It was a super old PDF file. It was so old. I don't even think it would open anymore. Anyway, I had to redo this, and I had to change the title. Curves every B student should know. Tangent, curve, cotangent, all those curves. Hey, and a circle. You go, Mr. Judge, you got to know what a circle is. And what's this other shape, by the way? An ellipse. You guys remember? So there's equations of circles, equations of ellipses. They're actually called relations. Okay, they fail the vertical line test. So they're really relations. So you say, oh, we got some relations. We got some, oh, what is this? We got the two types of what? Hyperbolas. Vertical and horizontal. All those nice shapes. And then I start to put the patterns together for you guys here, right? You go, wow, you got some of these x squared, x to the fourth, x to the sixth, x to the even powers look similar. The odd powers look similar too. You guys see them even by colors, you know. So, you know, those are some important things to know as a reference in a calculus course. Very important to know. And you say, well, why, Mr. Judge? Why would I want to know some curves? Because in all honesty, you could look at calculus with a lot of different, I should say, perspectives. One perspective is that you're analyzing, really using tools to analyze a graph. Analyze these curves. There's a lot of tools to analyze curves. Now, that's a perspective. So we're going to use tools to analyze curves. Like what I'm looking at here. Yeah, there's a lot of ways we can analyze them. And they're actually related to a lot of physical properties. Like I just got through teaching a trig course. You guys may not realize. In a trig course, it comes down to studying circles and triangles. Just studying those two shapes, you get so much information. Well, just studying attributes, properties of curves like you're looking at here, gives you a lot of information too, a lot of stuff that can be applied. So just diving into that, you know, you're going to realize, whoa, there's more to it than meets the eye. There's a lot more to it. So that's kind of the idea. It's just this perspective. So, you know, this is why we always start with a very big and important idea in calculus. It's a fundamental idea. It's a basis of calculus 1. And it does have to deal with, a lot of this comes down to looking at a curve. So that's why you want to know them. You know, you get to be familiar with them. So, you know, wherever you're at, you can download that sheet for yourself, this resource. And you could use it for any class that you're in. And these are just curves every B student should know. Now, remember, you say, okay, that's one. And then, yeah, you say, what am I talking about? We're going to start talking about a limit. And, you know, we have what's called a graphical approach. Graphical approach. I think I got to double check. Trigonometric limits, all these nice concepts. But I'm going to start with some notation and some ideas. I got to double check. This doesn't make sense to me. But it's not like our internet is fast. Oh, whatever. We'll see. We'll wait to it to go through this. So here's what I'm going to start with some of my notes, ladies and gentlemen. Okay? Remember, we're going to start with this idea called a limit. All right? You got this idea known as a limit. And that's where you start with calculus, okay? Now, remember, you say, okay, Mr. Judge, you just got through talking graphical. Well, there is something called a graphical approach. We're going to talk about that. But I start with the numerical approach. And then you have the algebraic approach. Good morning. So, ladies and gentlemen, we got this very important idea called limits. That's a foundation, really, of calculus. The idea of a limit? Yeah. So we got these things. So we're going to have to look at this. Yeah. Okay, that's interesting. Yeah, I mistitled that. So if I go, for example, you go back to the browser. You guys remember how I kind of we're looking at some notes here for this, okay? Now, when you take a limit, it doesn't even make sense to talk about a limit unless you have to look at the context of it. So what you guys need to know is this thing known as a what? If I write down that notation, what does that mean? This is known as a what? This is a function, ladies and gentlemen. What's a function? What's a function? I want you guys to know. Very often, AI. Is that AI? Bots. Okay, a function, ladies and gentlemen. What's a function? Just kind of, what's a function?
I would say it's more like a coordinate. Like when you put like X, it generates Y. Like,
Well, yeah, you're right. But you can think of it. Like I said, here's what I would say. A function you can think of as a machine. A machine. And okay, well, what's a machine? Like a very simple machine. Functions are everywhere, ladies and gentlemen. This notation for some people is where they have their first problems, is they don't even know what a function is and how that really kind of works, right? So a function, ladies and gentlemen, a machine, this is a special type of machine where you say, okay, what's X? X is an input. So every input will give you a what? Output, okay? And there's a formal definition of a function where, you're using that same language, okay? We actually say it's a rule. So if you say, well, what in the world is a function anyway? Well, it's a rule that assigns every input, and that's represented by X, to an output, which is represented by what? Y. Okay, so every input, and again, a function's a rule. Trying to find the colors. Every X value gets assigned to every what? Y value. Okay, so this is the technical definition of a function. So, when I teach courses like intermediate algebra, pre-calculus, yada, 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 all those nice things, we look at these functions. I look at it as a machine, and, you drop an input into a machine. So here's another classical picture. You'll see this in a lot of math books. Okay, like a machine kind of picture. You drop X in. You get really what's called f of X. You apply the rule on X. What we call that's the Y value. Okay? So you guys okay with that? You guys see my point? That's kind of clearing out some cobwebs. X gives you that Y. Right, here's your f of X. Okay. Give you a few more definitions. Right? What do we call the domain of the function? Do you guys remember what the domain is? Yeah, what's your domain? It's the set of all input values. So you're going to say this is going to be the what? The set of all what? Input values. So every function has a domain. Good. It's all the X values. Every function has a what? Range. Okay, what's the range? It's the set of all what? Of all output values. So you might say, is this important? Yeah, it's very important actually. So traditionally, you're going to see this kind of picture surrounding the idea of a function of a machine. So if for every input you plug in the value of X, it gives you an output. You go, okay, you guys with me on that? For every X value you plug in, you get a Y value. That's the whole idea. So in my notes, and I got to change the title. This is actually not graphical, it's a numerical approach. You go, how do I know this is in my notes a numerical? You're going to see. So in this first example, okay, let me kind of go back and take a look. F of x is the square root of x plus 1. Okay? You guys with me on that? So you would say, okay, what are the x variable is your input. And you say, but Mr. Judge, I don't see a y variable. Well, no, but the whole thing is your y. So they're going to say, y is that f of x value. All right, so the input value is x. With this function, the rule is it says add 1 to x and then take the square root. You guys with me on that? That's what this function says to do. So when you look at this, let me give you guys some notation here, right? We're looking at what we abbreviate this. This is the limit of the function f. Okay? And then you have x with the arrow a. So we're going to talk about this notation. Okay? Your x value is going to a for this particular function. So focus on this portion down here. Okay, we're focusing on really that. So we're going to see, okay, what does that actually mean to say x? What does this mean if I write this arrow, x goes to a? Do you guys know what that means? What does that mean?
It's kind of like approaching from both sides.
Well, it means yes. What we're saying is x, quote unquote, approaches what? Approaches an a value. So this is an approach, this notation. This is new. This is actually a new idea for people. Okay? So, but here's an issue. When they say x approaches a, there's more to the story. You say, what do you mean? Well, let me draw the real number line because this is kind of the standard picture. Okay, so here's another picture. You got an x value, okay, and here is an a value on the real number line. So we're talking about now, okay, x approaches a for some function, this notation. What is the issue? This is too vague. The issue of approaching a, that number, is too vague. Why do we say that's vague? Because what do they mean by approaching a? What they mean is this. You can start somewhere and you're getting closer and closer and closer to what? The a value. You guys see what I'm saying? That's what they mean by approaching a. So you start somewhere and you get closer and closer. That's what they mean by approach. Closer and what? Closer. And closer to what? To some a. A is a number. That's all. All right. But what if you started over here? You go, what do I mean by that? Well, you can start to the left of a. Is that right? Or you can start to the right of a. Because this is too vague. X is going to a. Okay. I can start to the left. I can start to the right. What does that mean? Getting closer, and what? Closer to a. That's what approaching is. This is new. So, how do we make the distinction? Well, x approaches a, x approaches a, you're going to see it this way, the power negative and the power positive. This is notation. So if I look at my notes, you guys see, oh, we got powers that are positive and negative powers like that. It's not algebraic in that way. This is just notation. This means they should have just said this. A approaches L. A approaches R. This simply just means what? Left and what? Right. That's what they mean. You're approaching from the left, you're approaching from the right. All right, you guys okay with that? So they're being specific when you see this. They're being vague when you see this. Okay, now let's look at what they really mean. So, for example, you can see the limit I put here, x approaches 3 of that function, square root of x plus 1. This is going to equal something. You see this, the limit x approaches 3 from the right here, x plus 1. Okay? So there's actually two questions you're looking at right now. X is going to 3 from the left. X is going to 3 from the right. Okay, so we're emphasizing that kind of notation right in here. And we want to see what that means. What's our function? The square root of x plus 1. Square root of x plus 1. Okay? So what I do here, for the most part, to start off, is we're going to look at Microsoft Excel. Okay? And, you know, it's a kind of a nifty tool. Let's go back here and share it with you guys here. This is X, and you know what I do? Let me go back down here. I say this is my X value, and let's put everything in the middle. And so X, this is the left approach. Okay. This is my function. I got to do it this way. I apologize. I'm going to put a parentheses, X plus 1. This is the power key caret, and I'm going to put 0.5. I can put 1 divided by 2, I guess. Okay. Now I'm going to try to make this bigger. Okay. And let's see, how does this look? I guess you can kind of see it. Let's make it bigger. Get you out of the way. Okay, there you go. All right, you guys with me on that? That's the square root of x plus 1, really, notation-wise. All right. So here's the thing, though. We're going to look at the approach to the number 3. So maybe I'm going to write that down. I'm going to say x approaches 3. What's the issue? Oh, I'm supposed to do everything I said it to do. What's going on? 16. Okay, what's the issue? Do you guys know? Come on. We want to know where you what? You have to have a starting point. So for both of these, copy, place. The issue is where you start. Okay, so when you deal with this, They don't tell you where to start if you're going to approach 3. Okay, so I'm going to go back over here. Remember the picture. X approaches 3. You have a real number line. 3 is here. You're going to start from the left. We're going to start from the right. Now, where do I start? Anywhere to the left of 3. What's to the left of 3? What numbers are to the left of 3? There's a lot of numbers. So I may start with 1, and then what am I going to do? Get closer and closer. Is that right? Then I'll get to what? 0.5, and so on, get closer and closer. I'm approaching 3 from what direction? From the left. So let's see. And what I kind of do, I'm a little bit more systemic here. What I mean by that is, okay, I'll start with 1, then I'm going to go to 0.5, okay? And then maybe 0.7. Am I getting, sorry, what are we approaching again? 3. I drew the wrong picture. I got to wake up. If I start with 1, I can't go to 0.5. I got to go now to what? 2, 2.5, and so on. Is that true? All righty. Okay. All right, we got to wake up. So I don't go to there. I go 2. Am I getting closer to 3? What about if I said, now let's do 2.5? Am I closer to 3? What about 2.7? Am I closer to 3? How about 2.9? Ooh, that's really close to 3. Is that right? Can I get closer? 2.99. Can I get even closer? Yeah, I can get 3 9s. In fact, what's the pattern? I could get even closer by going, what, 4 9s, and then getting, what, 5 9s, and so on. Is that right? 4, that's 5 9s. Now, is that really close? Well, it's kind of close. I could keep getting closer. So close is kind of relative. You guys okay with that? He's like, what do you mean by close? Well, how close? Well, that's kind of close. I can get better and better and better. That's the idea of a limit, though. See, a limit isn't actually necessarily reaching the value. It's just approaching the number, getting arbitrarily close to the number. Okay. So we're getting close to what number? 3. Now you might say, well, what's the point of you doing this? Well, we want to see what happens to the corresponding what? Y value now. Now, go back to this. You go, what do you mean? The Y value. For every X value, what do you have? A Y value. So Y, if you guys remember, equals f of X. So we're going to see something happen here. Y will approach a value as well. Y will get closer. If X gets close to a number, the question is, what is Y getting close to? That's a limit. X gets close to a number. What does Y get close to? That's a limit. It's just that simple. So when you do this, this answer is really the limit value they call L. L is getting closer to what number? Well, let's find out. You guys ready to see what happens? So what you're going to do now Excel does this nicely. I can just say, hey, take 1, take that value 1, add 1 to it, close that, raise that to the 0.5 power, because that's a square root. What do you guys see? This is an input value, and you got now an output value. So I don't remember, was our input values green maybe? I thought they were green. So I'm going to color this green, and I'm now going to want to see what happens here. These are the output values, the Y values. I kind of colored it orange. Okay, and I have a really weird, I do like to put the borders. Okay, well, let's try. That's when X is 1, input, output. What happens when X is 2? Okay, see that numerical answer? What happens now when X is 2.5? Okay, 2.7. Okay, let's go get closer and closer and closer to what number? Well, it's getting closer to 3, right? Is that true? So here's the idea. What is y getting closer to? Do we know? You say, I don't know what y is getting closer to. Sometimes when people see this for the first time like that, they go, I have no idea. Okay, I think I might be able to. Let's double check if Excel is smart. Let's see some. No, it's not. Oh, we need AI. Oh my God, it's not that smart. How many 9s were there? 5. Let's do 6. 1, 2, 3, 4, 5, 6. Isn't that closer? 1, 2, 3, 4, 5, 6, 7. Isn't that closer? 1, 2, 3, 4, 5, 6, 7, 8. Isn't that closer? 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't that closer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Isn't that closer? So what I want you guys to understand is what's going on here with the y value. And in fact, it looks like if I make that bigger, come on, Excel. No, Excel actually approximated. So much for AI. AI doesn't really know everything. Okay? So your value is approaching for X3. Maybe that's a better green. What's going on right here? This is my concern now. This is what I care about numerically. What do you guys see going on there? What's your y value getting close to? Would you say 2? How would you know it's getting close to a number? How do you know? Because you're looking at this, you said 2, even though you see the last number's 2. Sometimes maybe if maybe we can do this. Yeah, no. There we go. I just changed it on you. That last digit isn't 2. So how would you know that y approaches 2? Because this is the x value, and here's your y value, right? How do you know that that's getting closer and closer to 2? What should you see? Do you guys start to see the digits repeat itself? When you see those digits repeat itself this way, y is getting closer and closer to that number. Okay, so what you would say here, ladies and gentlemen, this limit is going to be what? This number is 2. Now, this is called the left-handed limit. So that y value goes to what? 2. Okay, the x value, we approached 3 from the left, and y got closer and closer to what number? 2. It's about approach. If I wanted to continue to get x to be closer, I can. What would happen? Y would get closer too. That's all. That's a limit. You're doing functional evaluation, really, to get to see where this gets to. Now, that's approaching from the left, right? You're approaching 3. So how do you approach now from the other direction? Where's the other direction? You can say 4. Isn't that to the right of 3? So you're going to have to know what numbers are to the right because you got to start. They don't always tell you where to start. And then what are you going to do? Maybe 3.5. And then you're going to get closer and closer and closer to what? To that number 3 right here. Okay, you guys see what we're doing here? So now we're going to get the right-handed limit. And we're going to see what that is in Excel. So the demonstration, numerically speaking, would be, okay, I'm going to start now at what number? 4. And then what am I going to do? 3.5. And then, can I get closer? What number again close to? 3? Okay, 3.3. Then maybe 3.1. How do I get closer in this way? Put now a 0, 1. Now, instead of adding 9s, add what? Zeros in front of the 1. Isn't that kind of close to 3? 3.001. How about 3 point what? 1, 2, 3. There's 3 zeros and then a 1. Isn't that getting closer? Then how many zeros now? 1, 2, 3, 4 zeros and a what? 1. And then how many what? 1, 2, 3, 4, 5 zeros and a 1. And then how many zeros? 1, 2, 3, 4, 5, 6 zeros and a what? 1. Okay, these are all my input values. How do we get those output values? Well, what do? You're now going to do what? The same thing. So we're going to take the cell here, add 1, close that, raise that to the 0.5 power. And ladies and gentlemen, there's your first output value for y. And then what do? What do you think the pattern's going to be? Anybody have an idea? These are all the y values now. So what's the pattern? Oops. Anybody see a pattern here? Where do the y values go to? What would you say? How do you know y is approaching a number? Because you're starting to see the number repeated. What number is repeated? That 2.000. And if you said, well, again, let's check to see if AI is any good. By the way, Microsoft has their own AI. Oh, see how it's not that smart. How many zeros now? 1, 2, 3, 4, 5, 6, 7 zeros. 1. 1, 2, 3, 4, 5, 6, 7, 8 zeros and a 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros and a 1. And ladies and gentlemen, and then it's saying, oh, it's 3. It's not 3. We're not going to 3. We're approaching what? 3. We're getting closer, closer, closer. We can't use 3 for a limit. We're not doing, that's not what a limit is. A limit is an approach. So get back out there and saying goodbye. It's just that it looks like it's just not set to a particular accuracy. So if I change the accuracy, okay, now what do you guys see here? The same kind of thing, is that right? So where is that limit approaching? Where's the y value getting close to? Y is in orange. What does that get close to? Ooh, that's horrible. It's not what I wanted to do. Y is also getting close to what? 2. All right. So your y coordinate, and that's a right approach now. Okay, that's a limit. We're approaching 3 from the right now. And then what's the y value going to? That's also going to what? To 2. All right, so let me write that down here, okay? So really here, it happens to be the same number. Does that always happen? No. And this is called, by the way, the what? A right-handed limit. Good. All right, you got the left-handed limit and you have the what? Right-handed limit. That's what this notation means. We want to learn that. But this arrow means approaching. Okay, now, by the way, this is a special situation. I want you guys to note then. Let's give you guys some notes. Just so you guys know, this is a special situation. You might say, what do you mean? What's so special? What's special here, ladies and gentlemen, is number 1. Let's say that. I'll give you the example. I can now give this answer. You say, what is this answer? You say, Mr. Judge, you're being vague. Yes, I know I'm being vague. But here's what I want to say. because they both approach the same number from the left and from the right. Let's think of it logically. They both approach the same finite number from the left and the right. So if somebody says to you vaguely, hey, what's the limit as x goes to 3? Well, it's from the left, it's 2. From the right, it's 2. You know what we can say? Oh, it's 2. Because it satisfies the left-handed limit value and the right-handed limit value. Okay, so let me write that down formally. All right? So here's what I want to say. Here's by definition. The limit, we say, as x goes to a of f of x equals L. If and only if and only if, the left-handed limit of the function equals L, and that's a key word, and the right-handed limit of the function is also what? L. This is an example of what I'm saying to you. Now, L, first of all, is a what? What do we call L? Do you guys know what L is known as? It's a finite number. It's a number. Like here, this is 2. So I want you guys to this is a very big important definition. You can call it a definition, you can call it a fact. What does if and only if mean? That's an equivalence relationship. It's equivalent to. And then you must have this happen. Both have to be satisfied. So when the limit from the left and the limit from the right both equal L, the same value, well, then that's the limit in general. So when they're vague, you can now answer the question. You guys okay with that? Trying to check something here. That's when they're being vague. Man, what do you guys think? Is that pretty simple? Easy peasy lemon squeezy? All right, I'm going to throw a monkey wrench into the system. I'm going to give you guys a nice monkey wrench. What did I say about L? What did L have to be? Finite. What does that mean? Finite is a fancy way of saying what? Number. Is that true? And by the way, there's some alternate notation. Let me give you guys some calculus 2 notation, right? What this is saying is the function goes to L as x goes to a. This is some, I like to give you guys a calculus 2 notation and calculus 1 as well, just to notate that so that when you get to calculus 2, you already know what the notation is. You guys know. But I'm going to throw a monkey wrench into the system here. You know what I'm going to do? I do this. I'm going to give you another function. This time I'm going to say x minus 1. Here's your function. So I say to you, okay, what's the limit as x goes to 1 of this function numerically? Just to give you guys an example, I'm going to change that function. I guess I don't even have to write this portion down, but you know, I want to give you guys this kind of, since we're on that topic. Okay. So I want to see this. So now I'm going to do it this way. I'm going to say, okay, let's copy some of this. Okay, and actually, in theory, supposedly, if I do it, I'm supposed to move all of them. All right, now this is a different function. So this is 1 over, I'll put parentheses x minus 1 now, okay? And of course, we have to clear this out. Okay, and we have to clear this out here. Anyway. And, you know, I think I did make a mistake, but it doesn't matter. Doesn't matter. Okay, I mean, I started on the wrong, doesn't matter. So I'm just going to clear this here too. All right, now it looks better, whatever. So what's our limit going to? We're going to 1, is that true?
Yeah.
So what's to the left of 1? If I wanted to start, what number is to the left of 1? You could say 0 maybe, is that right? Isn't 0 to the left of 1? Okay, now how do I get closer to 1? 0.5 and then 0.7 and then 0.9 and then 0.99 and then how many 9s now? Keep adding 9s. 3 9s. 0.1, 2, 3, 4 9s. 0.1, 2, 3, 4, 5 9s, right? I'm just going to look at some of these things here. So when I look at this y value by plugging that in, 1 divided by, in parentheses, 0 minus 1, well, when x is 0, the answer is negative 1. For y, it's the ordered pair, the point. And then what happens, ladies and gentlemen? What happens as I start to get closer and closer to what? 1. What do you guys see? Do you see the same thing happen as you've seen before? Do you guys know what I'm saying? Do you see the number repeating? I don't think so. How many 9s are here? 5. Let's do 6 9s. 1, 2, 3, 4, 5, 6. Okay, let's do 7 9s. 1, 2, 3, 4, 5, 6, 7 9s. Let's do 8. 1, 2, 3, 4, 5, 6, 7, 8 9s. And what do you guys see starting to happen? Do you guys know what that is? Looks like Microsoft Excel is getting a little nervous. No, what's going on? Yeah, I think we just stumped Microsoft Excel. So much for AI. Right? But what am I talking about? What are you guys looking at? Well, it's sort of increasing, but it's really decreasing. Right? You don't see the numbers repeating, do you? So what does this mean? Well, what do I mean about this? Let's talk about what I mean. Let's go back. What I want you guys to recognize, and you can't see it because it's, sorry, those people at home, and though people aren't at home. Well, I guess we don't need this. In this example, we can do this. Okay. I guess it erased it all. Who cares? Here's my point. Right in here, you don't see the number repeating. In fact, you see a negative number kind of getting bigger, but negative bigger is really getting smaller. It's a type of small. It's like, think of it as a deficit, as a debt. If that's how much money you owe, you're in bad shape. Do you guys know what I'm saying? So it's actually getting smaller in a sense. Not getting smaller close to 0 in a sense. Just it's owing money in a sense. Okay, so you're saying, I owe a lot of money. That means you have a little bit of money. Here's what I want to really say notation-wise. Notation-wise, that picture means negative what? Infinity. Notation-wise. Okay? Negative infinity. Now, you say, is that y goes to negative infinity? as x goes to 1 from what direction, ladies and gentlemen? That was from the left. Is that true? So as x goes to 1 from the left. Okay, negative infinity is actually a type of small. Now, what does that even mean? It means like increasing without bound, in this case, decreasing without bound. Without bound means there's no limit, right? Without bound, no limit. Compare that to the right-handed approach. You go, okay, what do you mean by the right? Well, what's to the right of 1? You can say 2 would be to the right of 1 or 3, right? It's where you start. They don't tell you where to start. So you start at 2 to the right of 1, and then you get closer to 1, 1.5, and then 1.3. I'm going to give you guys a systemic sort of way to do that. 1.01, and then what? Keep adding zeros. 3 zeros and a 1. 4 zeros and a 1. Isn't that close to 1? 5 zeros and a 1. You guys see what I'm saying? We're getting closer and closer to 1. What happens to the y-coordinate value is you say 1 divided by that number minus 1. Close that, and you get 1. I guess we don't need. Well, let's continue the pattern. What do you guys see happening for the right-handed approach? Do I need another 0? Maybe I can't see. Do you guys see what I'm saying? How many zeros now? What if I just put 1.1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros and a 1? Isn't that even closer to 1? And I just messed up Excel. Excel's going, again, so much for AI. So what's the point? Do you see that pattern repeating? Right? You guys see that pattern repeating? Say what? Say no. What does this mean? What are you looking at right here? What does it mean if you don't see the pattern repeating, the number repeating in the same way, kind of, but it's getting bigger, bigger, and what? Bigger. Right? If that were your checking account balance, you might be pretty happy. So what is the pattern here now? What would you guys say? It's going where? To now positive infinity. So if I said to you guys, what you're looking at is this. Let me erase this. That's not the answer. So the first answer is limit as x goes to 1 from the left is negative infinity. The limit as x goes to 1 from the right, and I messed up. I got to write down the function. 1 over x minus 1, and sometimes you see that in parentheses. Some actually instructors will say it's incorrect if you don't put the parentheses. I don't think so. You see a lot of books without the parentheses, but some instructors, they'll even say that to you. This is saying y goes to what? Infinity as x goes to 1 from the right. All right, you guys okay with that? So in one case, the y value went to negative infinity, and in the other case, the y value went to what? Positive infinity. So the left-handed limit goes to negative infinity, and the right-handed limit goes where? Positive infinity. So what's your conclusion then in general? You go, what if they say this in general? You say essentially that does not exist. You abbreviate does not exist. It's D and E. So you go, what? Yeah, D and E, meaning you can't describe it, ladies and gentlemen, if I can figure out, because they changed this. This limit does not exist. It's not going to the same what? Place. Okay? Not going to the same place. This is what we call a numerical approach to limit questions. Now, if you said, Mr. Judge, what am I doing? You know, I don't have a fancy computer with Microsoft Excel. I happen to have just my plain old what? Calculator. Well, could you do this with your calculator? Yes. Yes, you can. But do not, because I've been teaching calculus for a long time. You know what will happen? There's going to be some students that give these answers. You're going to ask them, what's the left-handed limit? And they're going to put negative 9990, 999, positive 99999. Because they punch a number in the calculator, and then they just give you this number. And then I mark it wrong. Like, what? It's like you even used a calculator and you missed it. Like, what? Why is it wrong?
Because it has no bound.
Well, yeah, what? See, this is important, ladies. The details are important. Why would these answers be marked wrong? You go, that, Mr. Judge, you are mean. That's right. These numbers, first of all, there's a lot wrong with it. Number one, you're not dealing with approaching. You're giving a finite answer when it's an infinite answer. Finite, what's the difference? Well, finite means number. Infinite does not mean number. Infinite is an idea. Now, I've been teaching this course and I've been using, I used to carry 2 backpacks with me set up in the morning. I used to have this big old, whatever it is, with sound effects. And I'll probably bring it back, but it's going to cost some money. Stuff ain't cheap. They have a smaller version. I got a smaller version because I can't be carrying 2 backpacks. What the hell? You guys know what I'm saying? Jesus. So I used to play this for students. I had a recording of, Buzz Lightyear. What did Buzz Lightyear used to say? Yes, to infinity and beyond. And you want to know something about Buzz Lightyear? He's wrong. What does that have to do with what I'm talking about? Infinity is an idea. Okay? You could never get to infinity. So therefore, you can't even get beyond infinity. Infinity is without bound, meaning it's an idea. Like if I said, it's way over there, it's infinite distance. End of story. You don't say it's beyond that, because saying beyond that implies it's finite. It's not finite. It's an idea. Finite means you get there. Infinity means you never what? Get there. It's a very fine and beautiful point. This is poetry, ladies and gentlemen. I mean, you think it's not. Who said mathematicians weren't romantic? I'm probably the most romantic guy you'll ever see in your life. Ask my wife. She goes, oh my God. And this is poetry. And you're looking at poetry right now. You could never get to infinity. Infinity is an idea. It's the direction you're headed. So it means, so there's a couple of very big problematic things. One thing, when you put these numerical answers, you're saying it's finite, and it's not. And you're failing to address this important issue here, that there's this, it's not repeating. It's getting bigger, bigger, and bigger, or smaller, smaller, and smaller. It's not repeating. So you can always tell somebody who doesn't study this stuff like that. Like, they didn't study it. They don't know what we're talking about. They're wrong. And they scratch their head. Well, I can use a calculator. Go, yeah. But on the homework, you know what it does? It actually says, it gives you some X values. It doesn't just give you one X value. It gives you some X values. And so it's kind of like training wheels. Like what I gave you here is the X values. And, and so does your book. It'll give you some of these X values and say, tell me what the limit is. So you have to do more than one input on your calculator. Now, could you use Excel? Yes. But on a test, what do you guys use? Your calculator. And this is just by the numerical approach. Now, I get to go to one of my most favorite now. And maybe the internet is better at the moment, I hope. Let me express this to you guys now here. I'm going to go to Desmos. And the graphing calculator in Desmos. I'm just going to kind of illustrate a few things here really quickly here. All right, you guys remember here, what was the function? Y, it was a square root of x, right? Square root of, is it x plus 1? All right, and I'm going to change the color. I use red for other things. Okay, now what was the limit, by the way? The limit was, and this thing, limit was x goes to 3, is that right? So let me put here 3. I think I'll put, what was the y value? Okay. So I want you guys to really see this detail, because you're really looking at some important piece of information here. All right, and darn. Well, I guess you can kind of see it. Okay, so you see that point on the curve when x is 3, y is 2? You're looking at the ordered pair, input, output. That's not a limit. That's the value of the function at the point. So when x equals 3, y is 2. But what you're supposed to see, as I scroll in, okay, what I want you guys to see is all the values of x on the left in terms of a graph here. What I want you to notice is all those points, right? You're approaching that point from the left. These are the x values here. You're getting closer, closer. And as you come from the other direction, right? I want you guys to see that kind of idea. This is the ordered pair of 3, 2. This is meaningful for us as well in our future. This has meaning in our future. But I want you to notice you're approaching that location. That's it. From the left and from the right. Now, this infinity and beyond in Desmos, you go, what does that look like in Desmos infinity and beyond? Well, I think the curve was what? Y equals 1 divided by x minus 1. Okay? And get rid of this, get rid of this. It's a different curve. Don't label it. And what do we approach here? I'm going to say x is 1. And I'm going to change that color. I'm going to make it, come on. Red, I'm going to dot it. And what do you guys see in this picture now? What am I talking about? As you approach from the left, what's happening with the curve? All those points, those y values are going down what? Forever. So the closer you get to one from the left, the further down you go to wherever that is. As you approach one from the right, what's happening with the points on that curve? You're going where? You're going up to heaven forever. And the other direction is going down forever, wherever that is. You guys see my point? You guys see what I'm saying? So you're looking at the approach, and that's actually what you're seeing. Now, technically speaking, in terms of curves, remember I started the lecture and said to you, these ideas about limits, right? Limits are used to describe curves. Well, guess what, ladies and gentlemen? This is called a vertical what? Asymptote. So this is the very technical definition, part of the technical definition of a vertical asymptote. You know, so we're really looking at a curve in detail with a lot of information. So you can get a lot out of it. And that's really the foundation. So all I'm going to say to you guys today is this. I'm giving you guys, I'll give you an assignment to kind of read about limits. In your book. We're going to continue tomorrow because, this is a pretty big thing to do. Limits, by the way. And so you go, where's the assignment here? Oh, yeah, we're crawling with our internet speed. Oh, here we go. Since we're out of time. So this is kind of the start of our limit discuss. Oh, what's going on here? Anyway, I'll fix this. Anyway, I want to get rid of all of it. How do I get rid of it all? Oh, there we go. Well, you guys can start to. Oh, some of it is actually there. Okay. Yeah, I don't know. We'll see so far. Let's keep that for now. Interesting. Oh, come on. Hate when things are not functional. Well, when you guys are free to go because it's time. When this gets up and running, it'll be up and running. Check assignment 1. It's reading 2.1 and 2.2 on limits. We'll continue tomorrow. And take care, you guys. See you guys later. Take care. Stay safe. Okay.